Hi everyone, in this video we're going to go over the stuff about transformations that you should have seen in Math 2. In class, we're going to do a little bit different types of examples. So go ahead and pause this video and copy down these notes before you go ahead and get started. All right, so when you're describing transformations, these are all your options in this graphic organizer, and you're comparing how your new equation or graph is different from the parent function. So it is super helpful if you identify the function and you remember what the equation of the parent function is. This way you can see all the different things that are new in your equation compared to what the parent function looked like. All right, so I'm going to be using that graphic organizer to help me figure out, based on where a number is in the equation, what it's going to do to the graph. So this first example, you should be able to tell me what kind of a function this is. I forgot to put y equals, but this is a function. You should be able to tell me that this is exponential. So the base of the exponential part is not a transformation. The base is just a part of the original equation. So if this is my new equation, my original is just y equals 2 to the power of x. So the 2 and the x were originally there, so those are not any transformations. But the minus 3 is new. So the minus 3 is one of these transformations. Based on where it is going to tell you whether it's up, down, left, or right. Because I could put parentheses around the exponent part, the minus 3 is with the x. We'll add that here. It's a left or right transformation. Because it's minus, it's actually going to shift the graph to the right. So this graph is going to shift right 3. The plus 6 is going to do something else. Because that plus 6 is outside, it's at the end. It's an up or down shift. So the plus 6 is going to move it up. At the end of the day, if you're not sure, graph it in Desmos and double check. All right, question number 2. You should be able to identify this as a square root function. So my original equation, the parent function, was just the square root of x. So the square root and the x, those are not transformations. Those were there originally. All right, there is something outside that's being multiplied to the function. So that is this beginning area of the graphic organizer. This is the stuff that's being multiplied to the function. So I see a negative sign in my example. So if that number is negative, it's going to reflect over the x-axis. Once you've used that negative sign, you are not using the negative sign to help you figure out if it's been stretched or compressed. The negative sign is only a reflection. Again, the negative sign has nothing to do with whether it's going to be a vertical stretch or a vertical compression. So once I identify the negative, so I can say, all right, I know that's going to be reflect over the x-axis. And when you're doing these, if they're open, like open sentences for you to write, you do have to tell me that it's been reflected over the x-axis for full credit. You cannot just say reflection. All right, so now that I have used the negative sign, I am going to ignore the fact that that number was negative and look at the 4. The 4 is going to tell me whether this has been stretched or compressed. So since 4 is bigger than 1, this graph is going to appear vertically stretched. It's going to look like you took the parent function, you grabbed the arrow part of the graph, and you pulled it up. When you're telling me stretch or compress, you have to use vertical. You could also use horizontal. I usually just stick with vertical for consistency. but vertically stretching is the same as horizontally compressing. When you vertically stretch something, you're pulling it up. If you were to horizontally compress it, you would be coming in from the sides and pushing it in. So horizontal compress would make the graph skinny as well. All right, same thing with a vertical compression. A vertical compression, you're coming in from the top and bottom and you're squishing it down, which is going to make it go out. So that's going to make the graph appear wider, but it will also appear wider if you grab the ends and horizontally stretch it out. So just be aware that you can use the word horizontal. So when you're saying stretch or compress, it is important that you tell me which direction. So I can either say that this is a vertical stretch, or I can say it's a horizontal compression, and both of those mean the same thing. All right, I have a +1. That +1 is inside with the x. So plus is going to move this to the left one. And that +12 that's at the end is going to move it up 12. All right, one other thing about the up and down, I could easily put the 12 first. I'm just going to write it small down here. But if I wrote this as that equation, those equations are the same, and so they would have the same transformation. That's a +12. That is just outside of the function. A -4 is still being multiplied. So just be aware that that plus or minus shift does not always have to be at the end. I can also put it in the beginning. All right, this would be a good time for you to pause the video and try number 3. All right, so I see a number out front. So 1/4, because 1/4 is less than the number 1, it's a fraction that's smaller than 1. I didn't need to use purple. That is going to make the graph appear wider. So you can either say that's a vertical compression, or you can say a horizontal stretch. Those are the same thing. It's going to make the graph appear wider if you compress it down or you pull it out. All right, you should also be able to identify that this is quadratic. So the parent function was y = x squared. So the x and squared, that was there originally, but the -2 is new. And since the -2 is inside with the x, minus is going to shift it to the right. All right, so make sure you have all of those down. We're also going to practice writing equations ourselves when they tell us what the transformations are. So it's telling me that this is going to be an absolute value function. So I'm going to write down what the parent function is so that I know what it's supposed to look like by the time I'm done. So I know absolute value has those bars. All right, it has been vertically stretched, and I purposely didn't tell you what to vertically stretch it by, so you would have to make up your own number. But if you're going to vertically stretch, that's going to make it appear skinnier. So we need any number that's bigger than 1. So any number bigger than 1. Reflected over the x-axis. So reflected over the x-axis means that I'm going to have to make that number negative. 8 units down. Down means I'm going to need a -8 on the outside. And let me reread it just to make sure I didn't miss anything. Vertically stretched, reflected over the x-axis, shifted 8 units down. So that looks like we're good. All right, so here's how you build the function. We can put that negative, and I'm just going to pick 2. You can pick any number as long as it's bigger than 1. That needs to get multiplied to the absolute value function. Now I don't have a left or right shift, so I'm not going to need to put anything inside of the bars with the x. But if I did have to shift something to the left or the right, it would need to go inside with the x. But I can close the bars after that because I don't have a left and right shift. I do have an 8 units down, so I need a -8 at the end. And there's my equation. All right, number 5. For some reason the graph didn't print from this. All right, so let me just draw one real quick. So here's my parent function. All right, so there's my parent function, and this is going to be my new function. All right, and I'm purposely going to exaggerate this. All right, and so we have to try to identify all the transformations. So if you want to pause it, try this, and then we'll do it together. All right, when you're looking at a graph, whatever key, vertex, or initial point, or if there's an asymptote, that's going to be a point of reference for where the graph got shifted left, right, up, or down. So if my old vertex was at 0, 0, my new vertex is at the point 3, 1. So I know this got shifted right 3 and up 1. I can also see from the graph that it's been reflected, and this should appear much wider than the original. I purposely did that. All right, so reflection means I know I'm going to need a negative. It got reflected over the x-axis. I have a right transformation, and I did miss something, so I'm going to have to make a little room. So I am going to have to move this to the right 3, which means I need -3. Up 1. So I need a +1 at the end. All right, and I forgot to make it wider. So I need any type of a fraction as long as it's not bigger than 1. So I'm just going to use 1/2. I'm just going to squeeze that out front because I forgot it. All right, I am missing one thing, and this is a super common, specifically with this type of a function. It's super easy to miss and lose just a couple of points, but this is quadratic, and so far my equation, this would be linear because it's just y equals x. So in order to make it quadratic, I need my x to be squared. If it was cubic, you would have to obviously make that to the power of 3. If this was square root, you would want to make sure you put all of that under the square root sign, the x minus 3 under the square root sign. So it's kind of one of those things that you should always go back and check. Did I make the function the type of function that it's supposed to be? All right, if you need to rewatch this video so you can get all of these examples written down, and we're going to do a lot more together in class.